Hello everyone, hope you're all healthy and are doing good, and welcome to the session of IIT JEE Achievers. This is Gyanendra, and as we have been learning chemistry for long, you already know me. So we today are here to discuss something about the questions of the topics that we have already covered. We've talked about the chapter of what do we call alkyl halides. We'll be discussing or continuing with the questions that has been asked in IIT and few other questions as well. So we would get an idea of what kind of questions are actually going to be asked and how do we tackle them, right? So we would get familiar with it once we are going to practice this type of problems, all right? So what you should do, what we should do is try to understand the type of question that comes and the way to approach them. Understand how is it that you should approach a problem in order to get to an answer of that. All right. So don't worry if in case you don't understand the question. We'll understand or try to understand in a way which could be related back to the topics that we have studied. Okay. So let us start with this then. Yeah. Before starting, this is about me. I am Gyanendra Sir. I have been teaching in different places for around 7 years, so I have enough experience in the field. And with that known, let us move further and start this session. Yeah, many people have been giving this exams or mock tests, and many think that giving the mock test or exams aren't going to be very helpful. For those who are not giving the exams, it is just a suggestion that writing the exams or mock tests are going to be helping you. Why? Because no matter how much you study, unless you practice it, you don't know. Are you able to fetch whatever you have learned, or it is just going? Okay. So what you should do is you should try to learn and then reciprocate it by solving the problems. If you are able to do that and get to the solutions and answers very well, then that's very, very good, right? Otherwise, things are going to become difficult. So you have to practice as well. Apart from learning something, do the practice too. Okay, then with that known, let us just start, right? So we have this question here which says, what is the main product of the following reaction? Okay, we would have been, I mean, this is a general idea, the general kind of question that has been there, okay, in different types of IIT JEE exam and different years IIT JEE exam. But this is a simple problem though, which could easily be answered. But could you guys try and let me know what would be the idea or what would be the answer that you would use here? We'll just give it a try. It's very simple to understand here. Two possibilities seems to be there. First, what does this NaOET represent? In the presence of ETOH, it is ethanol, right? CH3 CH2OH. It is an alcohol, and I would have already told you, in the presence of an alcohol, the action of a base dominates. You have learned two things. Like ultimately we have OCH2CH3 minus. This is what is called as NaOET. Okay, so it gets splitted into Na plus and OET minus. This OET minus is going to be having two types of behavior, and this behavior would decide the fate of reaction. What are the behaviors as NaOET would have? Let me just tell you. One thing that it would give you is Na plus. The other thing is O minus CH2 CH3. Now this thing here can act like either a base or a nucleophile. It could either act as a base or a nucleophile. Now we would need to decide, would it be better acting as a base or a nucleophile? How would you decide that? I've already told you, or I would have informed, or you would have learned that as well, that this can be very easily decided based on the medium. Just remember, for nucleophilic action, the medium shouldn't be something that promotes a base more. For example, water, aqueous medium. On the other hand, a basic medium would promote the basic action, the action of a base. What is a basic medium? Alcohol, you say, ammonia you take. Okay, some things like this are going to be helping the reaction to move or to act as if it is a base than a nucleophile. Now, what is the difference between the base and the nucleophile? The base is going to abstract a proton particularly, while the nucleophile does make an attack and substitute a leaving one. Remember that. So base is what is going to be dominating here. The reason being there is an alcohol present in the medium or as a medium, right? So substitution product isn't going to be the major one, right? And if that is not the major or the main product, this option is out of question. Now we know for sure that there is going to be an alkene prepared. Now we have two options. One is based on removal of this hydrogen. The other one is based on removal of this hydrogen. We'll observe what happens if the first hydrogen goes and what happens if the second hydrogen goes. I'll just make them in different color so that we could easily understand. So let us say the green hydrogen goes first by the action of a base. So what this base does is it abstracts that proton, makes the double bond, Br leaves. And what product does it give you? Let us just make it over here. It simply gives us, okay, a double bond over here. All right, now we could just count the number of hyperconjugation. Let us see how many of you can count it really well. 3 over here, 3 over here, 3 over here. So total 9 hyperconjugations are possible. Now if anybody would say, oh, what is the other type of other possibility? We'll observe that if in case that blue one is going to be released or blue one is going to be taken up by the base, then what happens? We'll see that as well. So this time this thing is going to abstract this blue one from here. That would again make the double bond, but it would just be making the double bond over the adjacent position. Again the Br would leave. So what is the resultant out of it? We'll just draw it over here. When over this side nothing would get changed, but over the other side you would get a double bond created, right? So this is going to be the other product. Let us just count or understand about its stability. To understand about its stability, you would need to understand about how many hyperconjugations does it have. So let us just see. One hydrogen is over here, okay, and with that hydrogen available, just give me a second. With that hydrogen available, we could easily understand that how the working of this thing could be understood. Like you could just see only just a single hydrogen is over here. That is over the alpha position. These are all the alpha positions. If you remember, identifying the hyperconjugation needs you to look at the alpha carbon having alpha hydrogens, right? So here just one hyperconjugation is there, and the other thing is inductive effect role. That is not very important. So we could clearly see that this is going to be more stable than this, and because of that reason, I hope you would have got the idea which one is going to be the correct answer here, right? But then is there any other possibility here? I mean, is it also going to give you something else? When there is this B option and then there is this C option. I mean, among this, if you'd see the stability, you could like understand or you could easily catch up which is the correct answer, right? So we have understood that it is this B that has got the most number of hyperconjugation, and that is why that is going to be the major product. I hope that is very clear to everyone. And what we have understood here is these two things. One is the action of nucleophile, the other is the action of a base. Nucleophiles would need aqueous medium, okay? It would need the aqueous medium. On the other hand, this would need alcoholic or ammonic medium, alcoholic or some solvent other than water. So these are the mediums that helps us have elimination products. So you remember that in case of action of a nucleophile, substitution takes place, okay? When nucleophile is going to act, or when the substance is going to act as a nucleophile, substitution occurs. If the substance isn't going to act as a nucleophile, sorry. If the substance isn't going to act as a nucleophile, but it is going to act as a base, okay, then what would happen? Then elimination occurs, children. Okay, elimination occurs. Usually an alkene gets prepared. Here, that would get substituted. Here, alkene gets prepared. So one is the medium decides that. After medium, there is something else that would also help us understand or tell which one would be the major product. Will it be the elimination product that is going to be major, or would it be the, what do we call, substitution product that is going to be major? The temperature, as I already told you, higher temperature prefers the reaction to have elimination. And yeah, children, do like, share and subscribe so that you could get all this content to you, I mean either live or recorded. Fine, then moving further, the temperature over here should be low or medium, doesn't matter much about the temperature. But here, if it is at high temperature, it would almost always be elimination. So remember that high temperature because of higher entropy, or normal temperature also because of higher entropy, would prefer elimination. But remember that at high temperature, elimination will be the major one that will be observed. Okay, so that is the next sketch. Apart from these two things, if the approaching group, if this nucleophile, if the reagent is bulky, okay, if the reagent is bulky, then also you won't have substitution taking place. If it is light or slender, then yeah, okay, substitution is easy, it is going to go and sit there. But if it is very heavy, it itself takes up a lot of space, it isn't going to go and sit there, it is just going to grab a hydrogen and run away. So remember that if the size of the reagent is bulky, or even the substrate also, if the size of the substrate has a lot of hindrance, then again base would be having its own dominance. So this is going to be light, and if it is bulky, it prefers having the behavior of that of a base. It is true both for the reagent as well as a bulky substrate. Okay, so it is not just for the reagent. Remember that point. So these things can actually help you very easily differentiate between elimination product to be the major outcome or the substitution product to be the major outcome. Many times we would have to choose between which one is going to be the major one. At that time, this is going to help you really well. So hope you would have understood this. With that known, let us move further and understand the next question, children. Keep on trying to solve these things on your own. Doesn't require much of an effort, but yeah, you would need to put some effort in order to get to an answer of this. So do try it and let me know, are you able to do it or you're finding it difficult? Okay, so let us just go ahead and try the second one. Which is the final main product or major product of the following reaction of trans 1,2 dibromocyclohexane? Now you have this trans 1,2 dibromocyclohexane. So we could see from here that bromines are already being shown. Now we could easily draw the hydrogens. Like here, the hydrogen would be in the dashed line, right? Because the bromine is in the wedge line. Here, the hydrogen would be in the wedge line because the bromine is in the dashed line. Now that we know that, we could easily get to the next stage. Okay, what is the next stage? Finding the answer, right? Let's do that. Let's try to find that. Now, we already know that here, you just have a secondary position. I would have told you primary, secondary, and then tertiary. This is the order to show SN2 reaction, right? And we know here either SN2 would occur or E2 would occur. Now, what is E2, SN2? You already remember. In E2 or SN2, always remember the kind of substrate that you have are similar. Why? Is because of the same reason that carbocation doesn't get generated. Okay, it is going to occur in a single step. And for that reason, they would have similar type of substrate or reagent demands. Although one needs base, other needs nucleophile. Okay. So in this case, no carbocation gets generated. Because no carbocation gets generated, we don't need to be thinking much here. We now know that it is either going to undergo elimination or it is going to undergo substitution. But let us say what is the, I mean, let us say that the reaction is going to undergo a substitution. Then what group is given over here is also an important concern, children. Now you can just see that 2 times it is mentioned. It would mean 2 things. Actually, well, literally they would have to write 2 equivalents or sufficient amount there. If they have not written, what they mean here is the medium also is the same. That means it isn't sufficient amount or ample amount. Okay, so what we can understand here is we would just need to look at it, and you could also see over here that these 2 things are different. This is the medium, and medium is alcoholic, right? Medium is again alcoholic. What is TBUOH? I hope many of you would already be knowing it. It's stirred butoxide. Okay, so CH3, COH, CH3, CH3. This is this tertiary butanol. Okay, that is the medium. That is an alcohol. And with this alcohol, we know what action would it show. It would behave like a base. And if it behaves like a base, what would occur over there? The elimination would occur, right? So we now know the major product would be an elimination product. It is not going to be a substitution product. Also observe, in none of the options we have substitution product. So that is a question which is easily answered, right? So now that we know that it is undergoing need to undergo elimination, we can very well understand the progress and understand which product would be the major one, right? So we could see here that there is going to be a hydrogen over here, or if that is the hydrogen, we could see that this hydrogen and this bromine, they are in the same direction. So if you remove this hydrogen, that bromine removal isn't going to work out. That will be known to you if you know E2 mechanism. So let me quickly tell you about E2 mechanism. What is this E2 mechanism? It's bimolecular elimination reaction or elimination mechanism. So just erase this part, as this part isn't that important. I'll tell you what is bimolecular elimination reaction. Elimination reaction. Now, if you want to understand the bimolecular elimination reaction, you would need to see the situation that is going to be needed in order to have this reaction happen. Let's say if one thing is over this direction, you have this hydrogen over here, the leaving group should be exactly on the opposite direction. This and this should be in the anti-position. What is anti-position? Anti-position is exact opposite position. Let's say if you've represented one with this type of line, let's just say one is represented with this over here, the other has to be represented with this over the other direction. That is going to make it anti. Okay, so that is what I mean by anti. That is a very, very important thing, that they have to be in anti position in order to make this reaction feasible. Okay, and that was the problem in the question that we have over here. The leaving group are not going to be in the anti position because they have to have, or they have to be present in this type of manner, which is not correct in the question, or in the question according to the question. So let us see how is it going to work out. This is exactly opposite. Now how and what happens, we'll observe that. You would still have the other groups as it is. Now let's say you've got this base coming up. What is the action of a base? We all know base is going to abstract the hydrogen. So let's say you have a base. We have a base. So what is this base going to do is simple. It would abstract this hydrogen, and simultaneously a 5-membered transition state gets created. At the same moment, this bond is going to take up the hydrogen. So the electron pair present with hydrogen and carbon bond would move to this place, causing or forming a double bond here. And with that, one of the leaving group has to leave. So what is going to happen here is we'd get a 5-membered carbon transition state before the formation of final product. I'll show you what is the 5-member transition state before the formation of final product, but in the next page. But yeah, remember that what has gone away from here, BH has been removed, as well as this leaving group has moved. The same would happen where with the other example, because that is the same. I've just drawn it differently. Okay, so this is going to go away. Now, what is important to understand here is in the process, a unique transition state gets created. Now, what is this transition state? If you observe over here, the bond would get broken, the hydrogen would get broken, a new bond with the base is going to get created. There will be another new bond that is going to be created over here. There is a bond that is going to be broken with a leaving. So if you count all of these atoms, you could just clearly see 1, 2, 3, 4, and 5. So all of these 5 atoms are going to be in the same plane. And that is what we call as a transition state with 5 membered involved. Okay. This is a 5-membered transition state. Okay. And all of these are going to be in the same plane. That's another important point. And all the atoms of this transition state, of this 5 members, among these 5 members are in the same plane. If you keep one of them over here, all of them would lie on the palm of my hand. Okay, and if I keep it like this, all of them would lie over here. Okay, so it isn't going to come over here or here. It is only going to be over the plane. Okay, so all 5 atoms are going to be on the same plane. For that reason, they have to be exactly opposite. They have to be anti from each other. Only then they would go out. Going to be on the same plane. That's a very important thing to understand. On the same plane. Alright. So this is the point that you would need to understand when you try to understand E2 mechanism. Elimination reaction by bimolecular process, or where the molecularity is due. Now if you'd observe, since the base and nucleophile, base and the substrate, both are involved in the rate determining step. Both are involved in the rate determining step. The rate can be written to be equal to K times the substrate times the base. Okay, that's why the order is 2, the molecularity is 2. But anyway, that is not important to solve the question. That is just needed to be learned. Now that we know what is E2, we are sure that if there is a possibility of E, it is going to be, which is not going to be E1, since the carbocation here isn't going to be stable. So it has to undergo E2. And we know it is elimination for sure. How do we know? Because there is alcohol as the medium. So what is it that is going to happen? You can't take out this hydrogen since it is not an anti to this bromine. And you may not say, you should not say that this hydrogen and this bromine from same carbon gets removed. That is not going to work out. This hydrogen and this bromine should have been removed, but then they are not in anti position. So definitely this hydrogen isn't going to be helping. Then which hydrogen? There would be one more hydrogen. Where? Over here. Now the other hydrogen, which is exactly in anti position to this bromine on the bottom, is going to be the one which would be taken out by the base. And if that is going to happen, it would abstract this hydrogen, cause a double bond to be formed, and this Br would leave. But wait. Don't you think there is another hydrogen above? Over here also you would have a hydrogen atom, which is going to be in anti position to this, right? And the other base, you would still have the basic medium. So base is in sufficient amount. Wherever there is a need, this base would go and does its work. So this base goes, takes out the hydrogen, forms another double bond over the top, and this Br leaves. And what is the outcome of it? I hope you would have all understood why is it C that is the outcome, because the one over the top would result in formation of alkene over the top on the bottom was because of this one's over here. So overall resultant would be 2 moles of BH that is being generated. Okay, apart from that, now this B is going to be the base which has abstracted the proton from the molecule. I hope it is clear and you have understood it well. And this is the type of reaction that we usually observe if in case the basic action is seen and you have an atom over the anti position. Alright, so let me know if there is anything that has confused you. Write in the chat box, comment box, and do let us know. Also, you could let us know in the Telegram channel that we have. Okay, we have the link in the description below, so do subscribe to that as well, or do subscribe to the channel. Alright, then we'll move further and move to the next question, which is the main product of the following reaction. Right, now how is it that you would find out this? You'd first again need to understand, is it going to be elimination or it is going to be substitution. How do we know? We check the medium first and then the temperature. Medium says it is alcohol. If it is alcohol, what product? Elimination product gets preferred, right? So we now know for sure that it is elimination. It isn't going to get substituted. And one more thing is none of the options seems to have a substitution product over here. One more thing. The group that is given over here, the base that is given over here is bulky. That's stirred butoxide, CH3, CH3, O minus. It is such a bulky group that it cannot go and get substituted somewhere. Instead, what it prefers is taking out the hydrogen. And that also there is some things that you would need to take care. It doesn't take out the hydrogen from any atom literally. There are specific atoms that could be the ones from where it can take out the hydrogen. Now, what are the ones from which it can easily take out the hydrogen? Can easily be understood by looking at the position where it can reach easily. You could observe that this is a bulky group. Reaching somewhere for it, I mean, in the deep is going to be difficult, right? So it would abstract something that is present over the shallow end, and that is over this carbon. You have a hydrogen over there, okay, and that is very easily present or approachable. So this would attack over that hydrogen. Once it attacks over that hydrogen, what is going to happen? This hydrogen would move its double bond over here, and with that double bond formation, the Cl, obviously that is the leaving group, that is going to be leaving from that. So you could just observe between CH3, now it would become CH2, okay? I mean, that CH2 over there would be over here, and which possibility seems to give you a double bond over the corner, either this one or this one. Now, if this is the case, you can clearly see that the double bond would be over the bottom, and that is over here, and then there is the CH, which is this one, and then there is the C attached to CH3, attached to hydrogen, and attached to this. Okay, remember that these ones are the flanking ones. You would represent them with wedge and dashed lines. Now, this is over this side, and if you look at it, okay, you would have it over this side, fine. We just flip it because this is the first carbon according to us. If this is going to be the first one, we are looking at upside down. So we would invert it. Like you could just see this is over the right and this is over the left. Okay. And you are flipping it around. For that reason, this is going to come over this side and this is going to come over this side. Like you can just understand. This is on the left if you just like that see. But if you flip it up, it would become the right one and this will become the left. You would have understood or learned that while you would have learned about Fisher projections, right? So that is why this is going to be a very possible answer, and this, because of the opposite directions, isn't going to be working out, right? What we do usually is we would check out from this direction and would see like the CH3 is over the left side, the hydrogen is over the right side. So when we place it, we do place it in that. But then because it is flipped in that option, it was like flipped over here as well. So C option seems to be a most possible answer. And yeah, that is the correct one. So hope you would have got the idea of how do we approach a problem of this type, right? So with that known, let us move further to the next one and try the next problem, okay? What is the next problem? We'll just see that. Which is the main product of the following reaction? Now the reaction is given over here and we have options again, but then the reagent here is similar. You still have tert butoxide and butanol present over here. Because we have tert butoxide and butanol present, it is again a base. It isn't going to work out as a nucleophile. It is such a bulky group first, and second alcohol is present. So there are two things that makes the reaction work out and act as a base. So let us just see how the base is going to work out over here. So this tert butoxide again is CH3, CH3, another carbon with methyl, another methyl group and O minus. And as I already told you, since you have an alcohol, the activity that it would show is that of a base, right? Remember that alcoholic medium shows us basic action, while aqueous medium would make it behave like a like a substituent, a nucleophile which would go and substitute something. So here it isn't going to work out that way for two reasons. One, because alcohol is present. Second, because it is such a bulky group that it won't go anywhere and sit. Now it has two options. There's this hydrogen over here and there's this hydrogen over here. As I already told you, you just imagine there's a very heavy guy, and this heavy guy has to go and fetch something from the corner, and it has to go all the way into the place and get something. Which one would be easy for a heavy guy who would find it difficult to walk? Simple, that it is very easy for that person or that heavy guy to abstract something from the edge, because when it would approach even closer, it would feel the repulsions due to the size, or the hindrance due to the size. That hindrance is called a steric hindrance, right? So remember that whenever we have a bulky base or a nucleophile, usually a base would be bulky, then the abstraction would happen from the corner. And if that is the case, you could clearly see what is the possible product of this. The possible product would be definitely the alkene, which would have a double bond over the corner. So this is the catcher. This is the idea that you would need to have while or when you would be trying to understand or answer this. Hope you would have got the idea and understood the way we have to approach this type of problems. Let us move further and try to understand the next problem. Which of the compound bearing different nucleophile Y and A and D gives the terminal alkene most selectively in the following reaction? Now this is the question given. Which of the compounds bearing different nucleophiles, okay, Y in A and D? Okay, what is this A and D? I hope A and D gives, among A, from A to D, from this to this, which one is going to give you terminal alkene most selectively? Now we have to find out which one can give you a terminal alkene. Like we have to get an alkene over here, right? This as the major product, or this as the major product. How can we find that out? Hello, Rishabh. Hello. So how do we know that? To understand that, what we would need to understand is you would have to have something that doesn't allow itself to get removed very easily, right? So we'll just see. If you observe the substance over here, this is a very good leaving group. If you remember, I've already talked about it. It is called as triplet. It's a very good leaving group, okay? OSO2 CF3. This group attached to this alkane, okay? Now we just need to understand, is this going to work out in the way that we want? If this is the kind of compound that we have, then it isn't going to work out that way, right? Hello, Dark Prince. 1, 2, 3, 4. You have 4 carbons. 1, 2, 1, 2, 3, 4. So 1, 2, 2, 3, 4. Yeah, this is the molecule. They're also here. Anyway, so we have this bond over here. Now, in this bond, you can clearly see that what is going to happen is this, that if this is the bond that is going to get broken, the leaving group would leave very easily, okay? And this molecule over here, which is having a medium as an alcohol, as I've already been telling you, if alcohol would be the medium, the reaction would be acting as if it is a base, or the reagent would be acting as if it is a base, and the reaction would result in elimination product to be formed. So we now know for sure that it is going to be the elimination product that would get generated over here. Sure, then we would move further and try to understand here. Now what would happen here is OET minus would have abstraction capability of this hydrogen, as well as it could abstract hydrogen from this place, okay? But then which one is it that is going to be giving you just an alkene over the corner? Is the one where hydrogen leaves first, okay? Now it is easy for a hydrogen to be left from the corner if, and we would need to understand it how. I'll just draw both the possibilities so that we get an idea of how this will work out. Okay, so let's say this hydrogen goes out. We have taken OET minus and we'll remove this hydrogen. when this hydrogen is taken out, you'd get a negative charge. So what would be the thing that would be produced is simply this. Okay, now if this is produced, you remember the negative charge could be stabilized by something that abstracts the electron. Now you know the last molecule over here, this wants to go away as easily as possible. It isn't going to have resonance in it. If you have a negative charge, it isn't going to have resonance in it. So this isn't going to stabilize it. Now among these three, you can clearly see that these three are electronegative elements. And the first option is very electronegative. So what would this fluorine do? It would stabilize the negative ion over the terminal position more. And for that reason, because it is most electronegative, it is going to be the one which would stabilize this the most. I mean, I'd let you know, or we'd let you know about that. Piyush, don't worry about that. That would also be starting soon. But anyway, now we'll be focusing more on IIT JEE. So because it is most electronegative over here, it would stabilize the negative ion the most. And if it is stabilizing the negative ion the most, it is going to be the product, right? And what would be the answer to this question? It is definitely the one over here, this fluorine, since its electronegativity causes that substance to be stable, right? So that is the way we would approach this problem. Let us move and try to understand another problem similar. Let us just see the problem first. Toluene, when treated with Br2 in the presence of iron, gives para-bromotoluene as major product because the CH3 group. Now we need to understand what is toluene, what is the CH3 group does, right? We'll see that. Now this is the molecule, and it is trying to react with Br2 in the presence of Fe. We all know that Fe is going to have, empty d orbital. Bromine has a lot of electron density. So in the presence of Fe, the Br would provide its electron to Fe, and this Br would become partially positively charged. And we know that benzene is a ring full of electron density. Okay. Benzene is a ring which is full of electron density. Many teachers and many students would already have learned that, like, if you represent benzene properly, you'd be knowing that in all the orbitals it has electron density above and below the plane. For that reason, it is going to be very densely packed with electrons. And wherever there is a feasibility of something to gain electrons, it would give the electron to those atoms very easily. Since this bromine, because it is giving its electron to this ion, it has got a partial positive character over the corner or the bromine atoms. So for that reason, this electron density would easily be shifted to this bromine, neutralizing the partial positive character over the other bromine as well. And that would cause this bromine to gain its electron density from these two places. One is over here, one is over here. So this benzene particularly is ortho-para directing. But then with this methyl group over here, due to hyperconjugation, its ortho and para directing behavior would be even more, right? It activates the ring because the CH3 group is going to activate the ring. It isn't going to direct the position or direct the atom to meta position. Then where is it going to direct it? Is either going to direct it over the ortho or the para position. In the ortho, it would be very close, feels repulsion. So which one seems to be the most probable or possible answer? In the para position. And that is why the answer to this question would simply be this. The bromine would come over here. And this is going to be the major product. So that is the idea of how you could easily approach this type of problems. Alright, then let us move further and try to understand even more. We have this next question. Among the following, which product will form to a minimum amount in the given reaction? Now we would need to see what are the possibilities here. Now they've given us the following reagents, and we need to find the product from the minimum amount of the given. So we need to find the minor product, right? Now we'd usually see the major product and we'd never be seeing the minor ones, so that becomes a little difficult. So let's first see which is the major product, right? You remember in the presence of sunlight, what happens is, here in this case, free radical gets generated. And if free radical gets generated, it gets generated over here, okay? And if it is getting generated over here, the substitution, I mean, because it is very stable over there due to resonance, it is going to be generating over there. So the most stable one would give the Br over this position, right? And if that is the case, that is going to be the product. And okay, so this is the major product, right? But we would want the minimum amount of the given reaction. Now which product will form to the minimum amount? Now it is a free radical mechanism. Free radical can get created over any place. Let's say a free radical gets created over here by the removal of this hydrogen. If the free radical would get created over here, you still would have resonance, right? But then if the free radical would get created over this place, would we have resonance from any directions? We would never have resonance from any directions. So over here, the free radical is generated in this place, and that would result this Br radical to come closer and form a bond, causing the molecule that is being shown to be formed. And with that known, we could clearly understand what is the possible answer to this question is simply the Br over the position where this there's some changes that done in the reaction. So we have this Br over here, we have this Br over here. Which product will form to the minimum amount? Now we could clearly see here that the product in this case would be the one where resonance would be there, right? You would have the resonance, right? And if there is this resonance over here, it would stabilize it and isn't going to be in the maximum amount. I mean, isn't going to be in the, what do we call, sufficient amount. But then this product, as what I've already been telling you, would only get generated if the free radical gets generated over here. If the free radical gets generated over this place, the Br radical would come in contact with that, and these two would share up a bond, form a carbon, form bromine over that place. And this is the minor product. It isn't going to be the major one at all. I hope you've got the idea of this and you would have understood that it is this one that is going to be the major product here. Right? So that is what is being talked about. That is what is being told here. Okay, so let us just move further. Try to understand more about it. In SN2 reactions, the correct order, this is the minor product, right? This is the least possible prepared product. In SN2 reactions, the correct reactivity of the following compounds, CH3Cl, CH3Cl2Cl, CH3 twice S. So we would need to understand like how would we find this out, right? So let us just check it out. CH3Cl, the other option is CH3CH2Cl, third option CH3C, CH3CHCl, and 1, 2, 3 carbons. 1 to 3 carbons. So you have CH over here and Cl over here. And then the tertiary one, CH3, 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 and a Cl over here. Now you could just understand from this that SN2 doesn't require us to have a tertiary carbocation created. And it would easily be happening in the one where there is no carbocation created. And that would be the one which is least hindered. I mean, primary and then secondary and then tertiary, that way. So which one has primary first, then secondary, then tertiary? B option seems to have that, right? So that is what is needed in this question. This is a very direct question and a very simple problem. So let us move to the next problem. The compound B in the given reaction is. C2H5Br on reaction with KCN and then hydrolysis would result. So we'll just understand what would happen with KCN. KCN gives you K plus Cn minus. Now Cn minus, what would the Cn minus do with CH3 CH2Br? We all know Cn minus is a nucleophile, makes the attack and throws away the Br. If that happens, it is going to give you CH3 CH2 C triple bond N. And with hydrolysis, what is hydrolysis? Addition of water in the presence of an acid. This bond is going to get broken down. Okay, and hydrogen of water would come over here, the OH part would come over this direction. So this bond between hydrogen and water would break 2 times, right? And once that thing happens, the resultant would be the final product. And that would be CH3 CH2 C double bond O. You would have 2 of the OH attached. And we know if 2 of the OH is going to get attached, what would happen further? It would get converted into CH3 CH2 COOH. And what would be the other thing being produced? NH3. Now which one seems to be a proper answer to this? The one with 3 carbons, propanoic acid, right? So that is our answer to this question. And that's the way we approach this problem and this types of problem, right? So with that known, let us move further and try to understand even more. What will be the product of the following reaction? The bromine is given with that and H2O is what is being reacted with, right? Now how is it going to work out with the product of the following reaction? You just understand here in order to try or to solve this, whatever is it. In order to try or to solve or to get to an answer of this, we just need to have a look at the option. The option seems to have a possible increase in the size of the ring, right? And for that to happen, you would need to see what reaction it would undergo. So we can see here the nucleophile is there, right? Or a base is there. It could either work as a nucleophile or a base. Since the medium is not mentioned, we're not very sure. So we need to look at the option and with that we could decide. See, all the options seems to have a substitution. So we don't need to decide. We know here substitution would take place. And now we would need to check out what type of substitution would occur here. Since the nucleophile is weak, we know what substitution would be caused by a weak nucleophile. SN1 substitution. If SN1 substitution would occur, we know that this is going to undergo a carbocation generation. Once the carbocation gets generated, you will see that it has been generated in a position where the carbocation isn't that stable. But if this bond gets broken and gets shifted over here, the ring wouldn't be a 4-member ring anymore. It would get converted to a 5-member ring, which would have lesser ring strain comparatively. So this bond over here gets broken and we could just understand that this charge, this would gain a negative charge, this would gain a positive charge, and then the charge distribution would move it in this manner. Although we don't draw it or show it in that way, but we know this bond is going to get broken down and would result in the formation of the final product. So you've got this new bond attached over here and the final one over here, right? And the carbocation would move to this place. If that has happened, you would get this generated. But you know, this carbocation is a secondary carbocation. It isn't very stable. So again, there is this hydrogen which would be undergoing a shift. What shift would we call that? A hydride shift. And this hydride shift would again bring the positive charge over to the terminal position. We could also draw it in this manner and write the positive charge over here. And then the water molecule would come in and go to this place, occupy this place, and our final product would be resulted because of this. And that is going to be something that has this and then the OH over here, right? Although you may get this OH over here as well as a minor product, but then this is also going to be produced. And for that reason, we would have got this as the major product. So this is the way we could approach a problem of this nature and easily get to an answer. Hope you guys are able to understand and approach this problem yourself. Sometimes the problem doesn't allow us to think initially. So we need to look at the options and then think again, right? Now this is the question, the synthesis of 3-octane is achieved by adding a bromoalkane with a mixture of sodium amide and alkyne. The bromoalkane and alkyne respectively are. Okay. So we need to understand what is it that is being used over here. The synthesis of 3-octane. What is this 3-octane? 1, 2. I mean, I'll just use this bond line structure since the number of carbon atoms has now increased. 1, 2, 3, 4, 5, 6, 7, 8. In the third position, we have the triple bond, right? So if we have this triple bond over the third position, how do we approach it? Let's just say that this is to be produced. Synthesis of 3-octane is to be achieved by adding bromoalkane and the mixture of sodium amide. Now, bromoalkane is needed and sodium amide. Mixture of bromoalkane, sodium amide into a mixture of sodium amide and an alkyne. Okay, bromoalkane, all right. Br, CH3, CH2, CH3, something like this. We'll just draw it for our understanding. Plus this other thing that is there. Now, among this, we'll just check out the possibility. Which one seems to be the most probable one? Here, 1, 2, 3, 4 carbons are there. 1, 2, 3, 4. So this is 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is also 8. All the options seems to be of 8 carbon members. But still, we would want the triple bond to be in a place which is over 1, 2, third position. Now, where is it over the third position? That is important. Here it is at the third position, and 1, 2, 3. Here also it is at the third position. But then we'll just count 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this isn't a possibility. That's why this is going to be the answer, right? So we need to count and check out for this type of questions how and where is there is high possibility for the product formation to happen, right? So many times the options could give you the answers themselves, right? And that is why this is going to be the answer here. Yeah. So with that known, I hope you would have got the idea and understood the way to approach many problems. Many of the problems or most of the problems from this have been asked in IIT JEE, and we were able to do that very easily. So we now know the way to approach them, understand them, and solve them very easily, right? Yeah, sometimes the question confuses you, like what is it that we have to do? Then we would have to think again. And yes, reading the question could give you an insight of of what is to be done. Also, the product should be observed once. That would also give you an idea. Okay. So with that known, we could move further. All right. So this is it, children. We'll continue with this and start the next chapter, maybe hydrocarbon or something, and then we'll understand a little more, and you'll get another idea of how to approach, solve, and answer any problem of the ones that has been asked in IIT JEE or anywhere. So this is it. Take care and all the best. But yeah, we have this Telegram channel. Do log into that, join that, and ask your doubts, any queries, anything related to IIT JEE or anything. And yes, don't forget to subscribe, like, and share so that other people and you yourself will be able to aware of whatever is being coming. Okay.